This is our control box. We have plugged it in the wall outlet, and it is right now 49 volt, or about 48 volt going to the ROV. Right here we have the tether. So that's the tether. This is the fuse, and it's about 8 inches on about 8.8 inches. So if you convert that, that's within 30 centimeters. And the fuse here is 30 amps. And right here, this is our service station. We have the 2 monitors, which go through HDMI to a HDMI hub, and it goes to a computer. We have a controller here, we have a router here, and everything is Ethernet connected, and the power is getting from a surge protector that is on the control box. This is the inside of our control box. We have a 120 volt AC power input from a wall outlet going through this power cord to this AC switch, which we can turn on and off the ROV. We also have a AC outlet that we can use for other external equipments. We have several screw terminals here are neatly mounted and very securely connected, so we can ensure that there's no exposed wiring. And these are neatly organized and labeled. We also have 4 DC power supply that can convert the 120 volt AC to DC power. We have this LCD display that can monitor the output and input power of our ROV. Our control box has 120 volt AC input, and it is converted to DC power using the 4 series power supply. And the 48 volt is directly wired to the Anderson connector to ensure that our ROV will be directly supplied with 48 volt DC.
All right, here's our air compressor, which provides our air to the ROV. It's our primary working fluid in the system. Back here, right there, we have a static relief valve. Here we have our tank pressure. Here we have our regulator pressure, which you can see also right here is at about 40 psi, as stated by MATE regulations. This red line takes our air through the tether to the ROV. And then down here we have another relief port, which if I open up, you see vent air. All right, here we have our red line running from our air compressor through our tether to the ROV. Right here, coming from the tether, we can see our red line and black line, which are attached to the ROV via quick disconnects. The red line is air intake, black line is air exhaust, which vents to the atmosphere. These are both connected to our pneumatics enclosure, which also has connections to all of our different pneumatic tools across the ROV, such as the primary manipulator right here, and the hinge for the primary manipulator right there. All components on the ROV are rated to at least 100 psi.
Okay, so this is our top strain relief side. We have the wire that's hooked up to a very heavy chair and very stable, so it reduces the stress on the pneumatics and the power cable. And this connects to the tether. And on the other side of the RV, we have the bottom strain relief. It's a very heavy, very strong strain relief, so no matter how hard you yank, it's not gonna do anything. In the strain relief, we have the power, pneumatics, and Ethernet.
So this is the top of the ROV. We have the box here. It's all waterproofed and sealed up. We have the foam here, which is waterproof and 3D printed. And then we have our thrusters, all with thruster guards, so there's no fingers getting caught. All the edges are very smooth. These were all machined, so same with the frame, was all water jetted, very exact, and no sharp edges. These are our 4 thrusters on this side. Again, all the thruster guards are here. We have waterproof cameras. And so on the bottom we have our pneumatics lines and stuff like that, and these are all waterproof, as you can see here, and no sharp edges. Here we have our primary manipulator and other foam, which was 3D printed. Same with the thruster guards, and these were all sanded down so they're not sharp. And here we have the rest of the thrusters. Again, all of them have guards on them, so no sharp edges, that were all sanded down. And here we have our tool here. This was the bird, so no sharp edges here. Same with the thrusters.
Going, I'm rolling, you count us down. We always roll.
Okay, 3, 2, 1, go.